want to no problem. When you're doing cylindrical coordinates, you're going to find it's way quicker. Now, I can't break it up because this has variables in it. Do you see that? So I'm going to have to integrate this first letter with respect to what letter? Z. So what's the integral of an R with respect to Z?
RZ.
RZ. And you're going from 18 to a R squared plus 2. Now plug it into Z. What do you get? I get 18R minus, what's R times R squared plus 2? I don't know. I'll just write it like that. Is that right? At least now I got it to a double integral. I'll put this down. Is that right over there? I couldn't split it up. This had the variables. By the way, this had 6 numbers. And you could break this up. You could do 3 separate integrals. You can do that if you want, but we couldn't split that up. What's that distributed? I now have 0 to 2 pi, 0 to 4, and 18R minus R cubed
Plus 2R.
plus 2R, which is what?
No, minus 2R.
Minus 2R. So how many R's would that be? 16R minus
R cube.
R cubed. Is that okay? I distribute that in combined like terms? Oh, good. You're all like, yeah, we do 2 steps at once. And I can split that up though. You know me, I like to split up integrals when I can. I've got 4 numbers. and I can rewrite this as theta times r. So I'm going to go 0 to 2 pi d theta. 0 to 4 of 16r minus r cubed. This is way easier than that tetrahedron problem we just did when we were talking maths. Way easier. What's that integral? 2 pi. This is the only, alright, what's that? 16r squared over 2 minus r to the 4th over 4. Put a 0 and 4 there. So I get 2 pi times 16 times 8. 16 times 8.
16 times 4 is 64.
That's 48 and 8. Is that 128? Minus 64. Make sure that d theta didn't get marked out there. D theta. What's 64 times 2 pi?
128.
And we just found the what? The volume. Is that a good ad? You got it there. Triple intervals. Hey, there's some problems on the practice set. When they go use cylindrical coordinates to express the given integral, so they already wrote out the integral. And I want to do one of these. And then after, we'll do another solve. Oh, you know what we should do? Let's do that, and then we'll do a problem where I'm like, hey, find the mass or something, and you just set that up as well. So here you go. First, I want to make sure, is everyone okay with this? Nice. We found this nice volume. Top Z, bottom Z, we recognize the projection being a circle. Go, is it go polar? Well, now we say go what? Cylindrical. Use cylindrical coordinates, which is r, theta, and z. Something else I want to talk about with cylindrical coordinates. Cylindrical coordinates is really r, theta, and then another variable. So let's say we projected this down on the xy plane. If you had something that was like up like this, and you wanted to project it that way, you could still use cylindrical, but you're missing that other variable would be like an x. Okay, I just want to give you an example of that. Can I erase this? Yeah? Okay, cool. X equal to where did I have this? Oh, it's on 15.8 problems. Flip it over. Tony, you see that problem in the back? There. Oh, I'll find it. Oh, everyone, I apologize. 15.5 to 15.7 problems. One did evaluate this. It goes evaluate triple interval of x dv e. And we'll just set this up. And they say e is bounded by x equal to 9y squared plus 9z squared and x equal to 9. So I'm going to draw this, but I want you to tell me how we could still use cylindrical coordinates even though this stuff has got x equal to and x equal to. You know what this looks like? Everyone, here's the x-axis. Can we just set this up? Where's x equal to 9? 2, 3, 4, 5, 6, 7, 8, right here. And here's that paraboloid, everyone. It started from the origin and just opened up like this. But again, it's going to intersect it in a what? In a circle. So if you're all concerned, oh no, I got to project this now onto the YZ plane, which you can. Because that's a circle there and the projection is a circle, you can still go cylindrical. The only thing is, rather than using r and theta and z, what should you use? Use r, theta, and x. Okay? That's what you can do with this problem. So you know what the setup would be? If I went cylindrical, I could still do it. There we go. I don't need much room for this. 0 to 2 pi? What's the top? And I have the next here. What's the top x? 9y squared plus 9z squared. If you go cylindrical, what should I write that as? 9r squared. Isn't that 9r squared? Because now y squared plus z squared equals r squared. Because I'm projected on this yz plane. So 9r squared, what's the lower limit? Actually, let me be careful. The top limit is 9. What's the bottom limit? I apologize. That'll be 9. This will be 9r squared. See it? Like that's the top, and this is bounded from below. This is that portion that's below, right here. That's below. The top is just this what? Right there, everyone, x equals 9. So that's the top limit. That's the bottom limit. That's got an x. What letter's automatic, Rach? I'm going cylindrical. R, dx, dr, d theta. Does everyone see that? dx, dr, d theta. Here's my two x's. The only struggle is finding what the radius is. Can you help me find it? Is the radius 9? No. Is the radius 3? I wouldn't try to shortcut it. I would do the math. Set this equal to what? Set them equal to each other so you can find the actual radius of that. Call it a disk. Call it a disk because we shade inside of it. What's the radius of that disk right there? 1. It is 1. It's from 0 to 1. So I want to show everyone. They said 9y squared plus 9z squared equals 9. If I got a 9, that's it. But now look, you can still go cylindrical on this. That will be an easy problem to work. Even though it was x. Because all we're doing is what? We're thinking projecting it like it's a z. Isn't that clear? Okay. Great job. I'm going to shade inside because the projection is really everything inside of it, right? Awesome. Can I erase? All right. Try this one. And when I want you to use cylindrical coordinates. Express the interval as an iterated interval. You'll see a problem like this on the practice set. They don't have anything here. Nothing. So all this is in Cartesian, right? They want you to go cylindrical on this. Use cylindrical to express the integral as an iterated integral. We just won't solve it. Got that right? Yep. Oh, wait a minute. They did have something there. I apologize. And when they had an XY here. They had an XY. Now, if they want us to go cylindrical, in fact, would you do me a favor? Let's make this XYZ. Hey, geometrically, in terms of real life application, what would this find? Do you agree this could find mass? This could find mass with the density is what? XYZ. Now, we're going to go cylindrical on this. So, what's that become? We're going cylindrical. Go cylindrical. What's this become? Good job. What's this? That stays what? 0? Rage happens all the time. What letter can I not forget?
R.
See it? I'm going to write it right away before I forget it. R. Whenever you go polar or cylindrical, you got to put it's an automatic. It's really R dr, but the dr comes down here at the end. What's X though? I can't leave that. What's that? Yeah, I got to put all that, isn't it? I got to put that entire what? R goes theta. All right, what's Y? R sine theta. What's Z though? Oh, in cylindrical coordinates, Z is just what? Z. dz, dr, d theta. Oh, we're rolling. This we got to be careful on. So let's draw that image. Before you rush this, especially on the test. Is that 0 to 2 pi? Is that 0 to pi over 2? Is that 0 to pi? Let's look at this carefully. These were what? These were x's. What were these?
Right.
These were y's. That's a top semicircle. What's the bottom? There we go. It's going only out to 7, -7. Is it shading everything? Be careful.
No.
Look carefully. It says only shade from
0 to pi.
0 to 7. Shade between these two curves. One's a semicircle. One's a flat line. But only shade from x equals 0, x equals 7. There's the projection. So we have to be really careful.
Oh, 0 to pi over 2.
That's dictating theta. Theta is not 0 to 2 pi this time. What is it?
Pi over 2.
0 to pi over 2. 0 to pi over 2. Now I know you know what the radius is. 0 to what?
Oh. Hey, another one, just set this up, okay? Is everyone on the practice set that you're doing? There's a problem like, all right, 17, find the volume of a solid, we know how to do that. 16, but stuff like number 18, where you go, which is this? This was just like number 19 from the practice set, all right? So here's another one. Don't evaluate it, just set it up. Owen? X squared dv e where E is the solid. That lies inside. And when they often use the word within.
that lies within a cylinder x squared plus y squared equals 16. And above by the plane, they wrote z equals 0. And below by the cone, when they didn't say by the plane, above the plane z equals 0. And below, when they give equation of a cone, z squared equals 25x squared plus 25y squared. Can you help me do this? E is the solid lies within a cylinder. X squared plus y squared equals 16. Known as a circular cylinder. And the solid's going to be above this plane, but below this surface right here. So I'll put an equal sign, triple integral. What letter's automatic? Pirate, RDR. What does x squared become? R cosine theta squared, dz, dr, d theta. So far so good? What's that? See, it's z squared. I need a z.
Square root.
What's the square root of, I can factor up to 25, you get a 5. But what's, if z equals the square root, I get 5
R.
square root of x squared plus y squared, right? What's the square root of x squared plus y squared?
Equals to R, right?
5r. So this is going to be above the plane z equals 0, but below by this, it's going to be below this surface. I can just call this 5 what? 5r. Someone see that? If z squared equals that, that's 5r. Now it's got to be within a cylinder. What's the radius of that cylinder?
16.
R squared equals 16, 0 to what? And they didn't say anything about only the first octant. This thing's unlimited, so it's going all the way around that cylinder. We didn't even have to draw this. 0 to what? Boom. That cool? I just want to look over to make sure we didn't miss anything else from cylindrical coordinates. Find the mass of a solid. No, we know how to do that. Oh, 21, they say find the mass of the solid within negative density. E is the cylinder. You want to use cylindrical coordinates, right? Awesome stuff. I'm looking over. I want to make sure nothing else been missed. Good job with this stuff. So you should be good on, this is the practice set. 16, 17, 18, yeah, that should be the last one to do it when we did one like 19. But if they say integral over something like this, I'm a race. And they said integral over x squared plus y squared plus z squared. How would you write that in triple integral? That would go here, and what would you write? This would become the r squared plus z squared. And I'll go dz, dr, d theta, and I'll start working on a problem like this on the problem set. And then Rach, what did I forget again? R. So that's what I'm saying, be careful. You can forget, you can let that R slip. There's always an R, automatic RDR data, you can put it in front. I'm always trying to hit on that, because you can imagine me writing it here and putting it here, how many times that happens on the test. But the student's like, oh, I can't believe I forgot, right? But that's when there was a problem, they said the integral over, and then they actually, the rest of this. This was like, this is like number 18. They said between planes Z and Z equals 0 and Z equals 2. What would that be? 2 and 0. But it said it had to be inside a cylinder with a radius of 1. So that'd be 0 to 1 and then 0 to 2 pi. Right? Do you all agree? 0 to 2 pi. 0 to 1. And then between the planes Z equals 2 and Z equals 0. The only thing was we had to make sure. Hey, and then tomorrow we'll do the last section. Awesome section, spherical coordinates. Then we'll get any questions you got. And if you're curious about spherical coordinates, cylindrical coordinates was great for anything where the projection was what? A circle? Spherical coordinates is great when you have surfaces that are spheres and cones. So it's kind of limited, but it's still pretty cool. Have a great day.